Hello everyone, today we learn chapter 9. In this chapter, we talk about interrupt and DMA, or direct memory access. After your study, you know about the process data transferring between device and CPU, and I show you to understand the concept of the interrupt and direct memory access and explain to you about each interrupt types in the computer system. We have four topics. First, talk about the data transfer between device and CPU, and then I show you the program I/O and interrupt, and finally direct memory access. In this picture, I show you the CPU or microcontroller. This is the microcontroller MCS 51. In MCS 51 have I/O port, timer, and memory EEPROM memory. For PCI for microchip have analog to digital converter and with modulator. And also in ESP8255, it have a wireless network and Bluetooth. So here in this, why I talk about the device in the microcontroller, because the CPU connect to a lot of device in a system. For here in this example on the microcontroller have about can you count here? This is a one, two, sorry, one, two, three, four, five, six device. This is a 6 device connect on the microcontroller. I suppose if you look at your computer system, in your computer system have uh, memory, memory address, device, and device have a small port transferring the data, USB device, internet, display card, a lot of device control in the system, connect to the in the system. So all of the device have a difference by data size. Some device running in 16-bit, some device run in 8-bit, and some device run in 32 bits. And some device response time a difference by if you send the data to the VGA to output to computers, the VGA running the response time very fast and data size runs data size when compared to mouse or keyboard. So here in this, I conclude the response time and data size shown on this table. Here in this table, we have three devices. That is a mouse, sound or video, printer or scanner. For mouse use the data size is a small data size, about a kilobyte or not up to megabytes during you move the mouse. The mouse capture the location X, Y or mouse surface and send to the computer. And for sound and video, is a medium size. Is the medium size maybe if you use the sound and video in the normal resolution. But if you look the video in 4K video, exactly the 4K video is large data size. For the mouse and sound video, this is the response time in the group of real time, and you cannot wait. You cannot waiting during your move of mouse, and then you waiting 1 second for mouse moving to the location that you move to. So, but in the printer and scanner is different. Printer scanner data size large and response time you can waiting from a page from but printing out from the laser printers. So here for the response time in a group of the real time we call synchronous. Synchronous has mean the all of the device things transfer the data at the same clock. And yeah, if the system or device run in the non-real time, we call asynchronous. Asynchronous this is when the device request to send the data is send a request to the system, and then system uh, open the port to get the data, like as a asynchronous, not the time for sending the not the time slot for sending the data. In the real time, when it send the data, have a time slot, have the same size in the time slots. Okay, here this is an example. In this example, I have three devices, device A, B, and C, connect to the CPU. And I suppose I write the code here. In this is like as algorithms. In this algorithm, I have variable x, y, z, and I have function wait until get data. This is the getting data from device A, B, and C. During getting data, it have a loop for. That means in each time of the loop, is get data from device A, then get data device B, and next get data from device C in this loop. During running in each loop, have some problem when the device B have do something broken and stop send the result to the system and stop running. So here in this, maybe the system will collapse or hang because it's waiting in this line until the device be respond. So here this is a main problem when you are use a computer. So some problem occur when you uh, try to connect the computer, the old system, try to connect to internet, try to connect to the some device and device not respond. Sometimes the system hang or stop running like this like as this same problem. So here this is a big problem for computer connect with a lot of device and management of the management the device connection. The techniques of the organization, the transferring the data divided into in three types. The first is the programmed I/O and interrupt I/O, and the third is direct memory access. We will look at each type together. First is the program I/O. What is a program I/O? Program I/O is organized by programmer write the code to control read sequence of reading or sending the data connect to the device. So some programmers have more experience or skill or control get the data from each device. But some programmer just do the works to the hardware, not have an experience for connect for making the connection, maybe making some problem in a system break or stop running. Example and in the program I/O, when the system have a lot of device connected, it is difficult to write the code to control read, write, or sending the data. I show you an example on the home security system in this picture here. I suppose this home security system. In this system have home security have a lot of device have this. This is a CCTV camera, and here maybe infrared or uh, um, moving detector or uh, this is like as uh, a detector, some detector, and this is a computer, door lock panel, door lock and panel, and safe safe box and smoke. And here in this is maybe like as some switch or in home security system have a lot of device in installed in a home, and in each door, each window have a detect switch detection detects or sensor open and close door or window status. So here in this have a lot of system, and in the have in the home system have a system have a software. The software read the data for each device here as recipient, read the data from each device and getting back. So here this is like as a big loop to read the device from CCTV, from switch, from computer, from any sensor in the home. But the problem occur when some device not respond. Some device not respond. Example, I support here smoke detectors not respond. So the smoke detector not respond during the system read in here is wait until the smoke detector respond the output. So here maybe system cache or stop running because some device not respond. Here in this, some programmer write the code by skip making a skip when smoke detector not respond about 1 minute 1 minute, the system will script it to read in the next device. So here, indeed, for the high experience programmer making the code by checking and skipping in the code of the system. So here, this is we call programmed I/O that is organized by the programmers. For here in this, I design to use the Arduino microcontroller to control the two switch to on off the to on off lamps. So here I think you have Arduino and write a C code to make a sequence of the program to read, turn on and turn off LED when you are test uh, move the switch on and switch off. So we will skip in activity 9.1 and I will show you in the class. Hello. Now we move to next topic. This is about the interrupt. What is the interrupt? Interrupt is a breaking process to service to do the service interrupt. Service interrupt is just a small code. After doing the service interrupt complete, the program moving back to run the remaining code on the main program. That means a program run in a main program and during have some interrupt signal, the program switch from the main program to do the service to do the service. The service is a small program or a sub-program. Then after run the service complete, it moving back to run in the main program. I suppose the situation that is the situation you are playing the computer game, and then your mother told you to lift a box. The lift the box, this is an interrupt. That is to stop the playing a game or pause the game to lift the box. And then after you lift the box complete, to move the box complete, you moving back to play the game. That is a like as the interrupts. In these pictures, here in this, I running a program in the user program here. This is like as a main program. During the system have some interrupt signal. I support the interrupt signal is generated from mouse when you move a mouse. The program stop from the main program and moving to the interrupt handler. Interrupt handler is a small program for service the interrupt such as mouse, and then run the service from the interrupt complete is moving back to run in the main program like here. For the interrupt, we can divide that interrupt in 4 types or 4 categories. First, that is a program interrupts. And second, that is a timer interrupt. The third is a hardware failure interrupt. And finally, it is a I/O interrupt. We will look at the program interrupts. The program interrupt like as a software interrupts. This is in a group of the software interrupt. I show you in this activity. Here, look at this activity. Look at the short code from the left-hand side here. Uh, on the left-hand side, I declare variable I and k. Look at line 6. At the line 6, this is a k minus 3. During running in the line 6, the program will occur divided by 0. Divided by 0. When you are tired calculators, the divided by 0 will generate the error. The error will from the divided by 0 may be stop running the program. So here, the program stop running or making a divided by 0. This is a generate the software interrupt. That means the interrupt from the software. That means interrupt from the software. So some software have set the service that is maybe setting every 10 milliseconds. 10 milliseconds. That means every 10 milliseconds that send a signal to the operating system to moving to service the software. To service the software. Yeah, this is a we call software interrupts. From here, from the second, third, and fourth, this is about the hardware interrupts. It's about the hardware interrupts. Here in this is activity 9.3. In this activity, look at the source code on the left-hand side. Here, in this source code, the code on the Arduino controller. The Arduino running here, not write the code about the interrupts. So at the code, look at line 5, 6, 7, 8, and 9. The line 5 to line 9 will generate the output by brings or turn on and turn off LED, by turn on about the uh, uh, 500 millisecond and turn off LED 500 millisecond, like as a turn on, turn off every 1 second. The program writing without the interrupts. But on the right hand side here, this is a short code about setting the interrupt. When you apply the code setting the interrupt, you cannot worry about the making the delay times. because the service from the interrupt, you can set the timer interrupts. Timer interrupt is a timer inside CPU. The timer interrupt you set the activation every 500 millisecond automatic. So here this is a answer from the source code example 9.3. If you have a time, you can bring an Arduino board and write the code right here to test the interrupts. So here in this is a declaration about the interrupt signal, and the program have the interrupt by the during turn on and turn off. The program have make an interrupt for service. From the third, here in this is a group of the hardware interrupt. That is a hardware failure interrupts that is generated from the hardware error by running the error. I think sometimes you have problem during you use the USB flash drive. During your use the USB flash drive and you copy the file from USB to your computers. During transferring the data, you remove the flash drive immediately during copy the data. The computer will show you error right here. The errors tell you about the problem ejecting USB by the copying during copying the data. So here this is about the hardware failure error. Hardware failure error. So the hardware failure error can occur from the transferring the data in the network when the network connection lost. And also the main point error on the computers that is a generate from a bad sector from hard drives, because some location on hard drives is the error. The hard disk try to read is list the location at the bad sector but cannot get the data. So here making the hard disk stop respond and so generate the hardware failure error and stop running to the system. So here this is the error from the hardware at the third. And the fourth, yeah, this is a I/O interrupt. What is the I/O interrupt? The I/O interrupt is a interrupt from the input, output, or external device. Example, in these features, a user listens to music. During he listens the music, he moves the mouse. He moves the mouse. During he moves the mouse sends the data to computers. By the mouse send the interrupt signal to computers. Mouse send the interrupt signal to computer. The operating system switch from the main program, maybe the main program that is music program to service the mouse. Like as this picture here, during the computer run in the main program here, and the user move the mouse and type the keyboard immediately. The computer switch to service mouse and keyboard, to switch mouse and keyboard. After service complete, the computer uh, moving back to run in the remaining line in the main program. So here in this, or the interrupts, I/O interrupt, and here we call the sequential interrupts. The sequential interrupt is mean the interrupt from two or more device, two or more device. So here in this, I have two device, mouse and keyboards. I I doing I doing by move the mouse and tie the keyboard immediately. At the same times, here in this is a generate a lot generates two interrupt from the two device. So the computer will select the device by check the priority levels. Some device have a high priority, such as interrupt from a music, interrupt from mouse. This is a group of the high priorities. Some device have very low priority, such as the printers. The printer, when you are during your print the document to printer, you can wait 1 minute or 2 minutes during for printing the papers because this is a low priority for printers. But here in this picture, I show you the next interrupt. Then the next interrupt is an interrupt during service interrupt that is a low priority. Or here in this, a computer service the interrupt in the printer and during at the same time you move the mouse. The computer switch from running the code in the service about a printer to to service the interrupt handler from the mouse. So here I conclude the interrupt from the I/O and divided by the no, interrupt from the I/O and also the interrupt on the computers and divided into group. That is a sequential interrupts and the next interrupt for time interrupt times. That is a sequential interrupt. This is a interrupt by priority levels. And here this is a next interrupt. This is an interrupt. And during service low priority interrupt, the computer can switch to service the high priority interrupts interrupt or the high priority device to do the service. Okay, now this is the last topic about direct memory access or DMA. I think you ever had this this problem about copy a large file from the CD-ROM or the hard drive to the USB flash drive. Maybe during copy, the hardware the stop or freeze right here. What is about the occur in the system? Maybe in this is occur when you use some system that's not turn on about the direct memory access or without doing about the interrupts. But don't worry for the new system if you buy a or i3 and run or i3 over or and run in a new operating system Windows 10, Windows 11, or the new version Windows system. That is the automatic turn on the DMA and use the interrupts. And if you use in the very old system, such as DOS or Windows number 3, Windows the third edition, maybe we had a you will have a problem about the DMA and interrupts to organization or turn on and turns off. Now, what is the DMA? The DMA is an abbreviation from the direct memory access. That means the transferring the data from the I/O to memory directly without organization or managed from the CPU. Or here in these pictures, in this is a no DMA system by the I/O transfer the data to memories organized by CPU. The data, some data pass to the CPU and then move from CPU to memory. So here, when that means during transfer a large data, that is a I/O device, another I/O device will stop or waiting until the bus wait until the bus free or until the CPU free. That means here, this is I suppose I/O is USB device or hard drive. Here in this, during copy runs data and some another I/O device connected that I suppose maybe a sound card or VGA. As is all of this is or another device will stop or waiting until CPU free. But here in this is a system by concept have a DMA. So here in the DMA on the motherboards have the chipset, have the chipsets. Inside the chipsets have some function about the DMA. By the first step, the CPU tell the motherboard, tell the chipsets to making the direct memory access. Then the the I/O I/O, for example, a hard drive, sending the data to the DMA module and send it directly to the memory without organization on transferring to the CPU by sending directly to the DMA module to the memory directly without the CPU. So here CPU have a free time, then CPU can do the service to the another I/O. So here in this is making the you running the computer without freeze or stop running. Okay, this is I think complete about the direct memory access. Now we move to the summary. To summary, I think for this chapter, we talk about the data transfer between device and CPU, and then I think you know the difference between program I/O and interrupts and understand about the direct memory access. Okay, I think complete in the chapter 9. Okay. Uh, for thank you for watching and see you for the next live. Thank you. Bye bye.